Assalamualaikum, my name is Balqis Binti Omar. My matrix number is BF17022443. Now I would like to present my part introduction for our group project. For our group project, we already proposed design, construction, completion, testing and commissioning of building and chamber equipment for the Electromagnetic Capability Center of the Faculty of Electrical and Electronic Engineering FKEE at University Tun Hussein On Malaysia, UTHM, Parit Raja, Johor. So in introduction, already have 4 parts. The first part is the background of study, second part company profile, third part scope work of study, and the last part is organization chart. So now I would like to start with a background of study. For our background of study is the soil investigation for proposed building and the soil profile of construction of FKE building at University Tun Hussein On Malaysia, UTHM. The design, construction, completion, testing and commissioning of building will be proposed and accomplished at the end of the study, and all the testing and site work was carried out at the site. For our background of study, we try to investigate whether which type of foundation will be the most suitable foundation that can be applied on the soil profile that we have investigate on construction FKE building in UTHM. This is our proposed site at Parit Raja. Next, company profile. We choose Jos Design Sendirian Berhad. Jos Design Sendirian Berhad fully Bumi Putra Consulting Firm registered with Company Commission of Malaysia (SSM). Aim of this company is to run a new consultancy engineering firm efficiently and effectively, adopting modern technical method and operational resources, and use AutoCAD and drafting to improve design and speed up the development. This company also have many multidisciplinary such as consulting services including structural construction, highways and transport, water resources and supply, sewerage and drainage irrigation. For this company have experience which is to design and planning of project plan, quantity surveyor and construction architecture, such as home, resident, parking lots and even bus parking in an operating office despite contracting. Jos Design Company located at the Johor Jaya, Johor Bahru. The company first founded at 1994 and registered at Batu Pahat at 90 August 2001 and established company 31st August 2008. Okay, mission of this company is to offer the best level of quality building and design facility at fair and affordable, to uphold the highest degree of professionalism, competence, transparency and justice in our interaction with our vendors, subcontractor, professional, associate and consumer, to ensure the durability of our business by repeat and referral business accomplished through customer loyalty, and the last mission to deliver sustainable value to our stakeholder and enrich life with the IJM mark of excellence. Vision for our company is to become a leading Malaysian conglomerate in the market reserve and to delivering excellent outcome for our client, building rewarding job for our employee and gain a good return on the value that we have offered. So scope work of company is to have 5 scope work, which is contract implementation, calling, evaluation of tender, mechanical and electrical engineering design solution, civil structure and geotechnical engineering design solution, conceptual planning, detailing the preparation of the master plan and feasibility study, and the last one is the project administration and supervision. So this is our organization chart. The director for our company is Wei Siang, project manager Yu Chelong, consultant engineer Chong Yee Hau, and architect by Balqis, and the last is a structural engineer which is Kai Xuen. So that's all from me. Thank you.
Hi doctor, my name is Yu Long and my matrix number is AF170247. So now I represent about the soil investigation. The site where the soil investigation testing was carried out is at the College University Technology Tun Hussein Batu Pahat, Johor. The work consisted of 2 boreholes as instructed by the engineer representative. The work was carried out by using YBM2 boring plant. Listed and unlisted samples were collected at various depths and the change of soil strata. The soil investigation testing consists of standard penetration test (SPT), groundwater observation, and laboratory test. The laboratory test consists of moisture content test, autobed limit test, and particle size distribution for coarse grain and fine grain, and also to determine the pH value and also organic content. Next, the summary of laboratory results. The laboratory test conducted on the selected samples from the 2 boreholes revealed the following results. The natural moisture content of the soil tested fell between 15% to 75%. The particle size distribution by wet sieving revealed the gravel content of 0% to 31%, sand content of 2% to 71%, silt or clay content of 18% to 52%. Based on the both autobed limit and particle size distribution test result, the soil tested belonged to CL, CI, CV, CE, ML, and MU soil when classified in accordance with the British Soil Classification System. Next, in general, the soil profile can be divided into 3 main layers, where the first layer is soft clay, followed by medium stiff clay, and the last layer is very stiff clay. The height of each layer was taken from the average height of borehole 1 and 2. And this is the example of soil profile. And after that, we need to calculate the correlations for N16, which is the standard penetration number in cohesive soil. On granular soil, the standard penetration test works very well. However, the efficient stresses are altered due to the poor water pressures produced while driving the sample to clays, which can affect the N values. As a result, clays are not reliable in the standard penetration test and the N value. Nevertheless, when N16 for clays is available, the consistency, undrained, shear strength, pre-consolidation pressure, and the over-consolidation ratio of the clay can be estimated using empirical correlations. Chee and Wei calculated the consistency index as Ci equal to liquid limit minus moisture content over liquid limit minus plastic limit. This is the table of approximate correlation among consistency index, standard penetration number, N60, and the unconfined compression strength. And our group was identified the soil properties based on the reference such as Borlaug report to identify the moisture content, liquid limit, plastic limit, and the Woods elbow to identify the typical unit weight of clay. And this is the book of Principle of Foundation Engineering to determine the range of wear ratio and Poisson ratio. And Haddon 1990 was used to identify the elastic modulus of clay. And this is the final soil profile after we calculate. And there was a water level of 1 meter below the ground level. That's all from me. Thank you, doctor.
Okay, my name is Chong Yee Hau and my matric number is AF170246. For my part of the presentation, I will explain about the design of foundation. So first of all, in our project, based on the soil profile given, it is obviously show that the earth is genuinely accepted. So the main component of the foundations are the pile and the pile cap. A pile is a vertical primary component of a deep foundation. Crust performed into the ground to provide DT beneath. So the next one will be the type of foundation. There will be 2 types of foundation, shallow foundation and the deep foundation. So in the shallow foundation, bed foundation is the type of spread base or consisting pad or rectangular, square, and often circular concrete that support localized single point load such as structure, column group, and frame structure. So this is used for the shallow foundation. And the next one will be the deep foundation. For both type of the foundation, small and large construction, reinforced concrete pile, square pile are commonly used. So they are ideally support the construction or building to be built in the wide variety of the soil condition, including the low-rise to high-rise infrastructure. Next one will be the type of pile material. So relatively, concrete pile have greater resistance to corrosive conditions that can rust steel pile or to the consequences that allow the wood pile to roof in similar situation, and concrete is abundant in most part of the globe than steel. So precast or cast in position may be the concrete pile. They can be considered pre-threshed or plain, as composed to ordinary precast. Reinforced concrete square piles are used in this project. The next one will be advantages and limitations of the RC square pile. So I will list one of the advantages and limitation. The first one is the advantage is stable in squeezing ground. For example, soft clay, seed, and peat pile material can be inspected before boarding. So the limitation is sometimes problem with noise and vibration. So the next one will be the design consideration of pile and footing foundation. So the final selection should be based on the assessment of the viability and comparative cost of engineering for possible solution, taking into account considerations such as safety, efficiency, buildability, and performance of the life cycle. For pile foundations, the following conditions should be taken into account during the pile design. The first one is the eccentricity of the load applied on the pile. The second one will be the condition of the pile at the top and the bottom of the pile. The third one is pile material compression tension capacity. The fourth one is deformation area of pile, bending moment capacity, and groundwater layer and the soil characteristic. Next one is the design step. For the design step for the shallow foundation is the first one is to attain the soil property from pole load. After that, we'll calculate the ultimate bearing capacity and allowable load bearing capacity. Third one will be the determine the size of foundations and then obtain the field penetration number. Continue with determining the depth or stress. Finally, we'll carry out the elastic settlement analysis. For the deep foundation will be similar to the shallow foundations. Will be the first one will calculate the ultimate and then self-carrying capacity for the pile. And second one will be arraying the number of the pile requires. Third one will be designed for the bulkhead. Usually consider a rigid member in the pile group, and then following with the calculate the distribution of force from the superstructure in the pile. Finally will be carry out the settlements analysis to ensure the settlement are within the limit. So last but not least will be the grouping of the loading, column loading. According to the drawing or key plan of foundation, column load can be categorized in the table. The column load have been categorized into 4 ranges, which range from 0 to 99 kN, 100 to 199 kN, 200 to 299 kN, 300 to 399 kN. So the table shows that the range of the load and also the maximum load of maximum column load. They were categorized in different column with the different load. That's all for me. Thank you.
Selamat sejahtera kepada Dr. Zaihasra binti Abu Talib. My name is Kai Xuen. Metric number is AF170243, and I will present the calculation, discussion, and justifications. So for the selection of deep foundations, in this project, we decided to choose deep foundation to support the column loads. As from the soil profile, we could observe that the top soil layer with 15 meter height was soft clay. So there are 3 main reasons why we chose deep foundations in our project. So first, the soft clay was considered weak soil layer as they exhibit poor strength and compressibility. So if we try with shallow foundation, it will not suitable. Hence, if we use pile foundations, it can be transmit the load to a stronger soil layer by the superstructure. So this figure shows how it works. So next, the next reason is the presence of horizontal force. So pile foundation resists bending when subjected to horizontal forces while still supporting the vertical loads transmitted by the superstructure. And the third reason was the concern for presence of expansive soils. So expansive soils swell and shrink as their moisture content increases and decreases. If shallow foundations are used in such circumstances, the structure may suffer considerable damage. So, I'll present the design of power foundation with calculation. So first, for columns C1 and C3, we'll try reinforced concrete square pile 3 meters times 3 meters. So from the result, the allowable load bearing capacity of the pile is 151.46 kilonewtons. So hence, the size of RC square pile 0.3 times 0.3 meters is suitable to withstand the load for column C1 and C3, which the actual load is 50 kilonewtons and 70 kilonewtons respectively. So from the result of calculation, the elastic settlement of reinforced concrete square pile 0.3 times 0.3 is 2.59 millimeters. So next, for columns C2, C4, and C6, we try square pile 5 times 5 meters. So from the result, the allowable load bearing capacity Q allowable is 267.6 kilonewtons. Hence, the size of this is suitable to withstand the load for column C2, C4, C6 with actual loads 200, 175, and 130 kilonewtons respectively. So from the result of calculations, the elastic settlement of reinforced concrete square pile is 3.13 millimeters. So for column C5, we try group pile of reinforced concrete square pile, which is 5 times 5 meters. So from the result, the allowable load bearing capacity of the pile is 489.8 kilonewtons. So hence, the size of this is suitable to withstand the load for columns C5 with actual loads 350 kilonewtons respectively. So from the result of calculation, the elastic settlement of RC group pile is 3.13 millimeters. So for consolidation settlement, the total settlement is 92 millimeters. So this table shows the summarize of the foundation applied on each column. So it can be seen that for the columns range from 0 to 99, which is C1 and C3, we use the size of RC square pile 0.3 times 0.3, which Q allowable 151.46. So for range of 100 to 199, which the column C4 and C6, we use 0.5 times 0.5 RC square pile. The Q allowable is 267.6. So for the column loads 200 to 299, we also use the single pile with 0.5 times 0.5 meters, and then the Q allowable is also 267.6. So for the column loads 300 to 399, which is the column C5, we use the group pile with the RC square pile 0.5 times 0.5 meters. The Q allowable is 489.8, which is suitable to support the column loads. So next, this is a drawing for deep foundation. So first, for RC square pile 0.3 to 0.3, we can see the plan elevation and front and side elevation. So next, the RC square pile 0.5 times 0.5 meters. It can be shown the plan elevation and front and side elevations. And lastly, the drawing for deep foundations for group pile of RC square pile 0.5 times 0.5. So it can be seen the plan elevation, the front elevation, side elevations. So above of the group pile, it will be one cover, which is pile caps. So that's it for me. Thank you.
Hi doctor, my name is Wei Siang and my metric number is AF170224. Now I will present my part. So I will present about soil improvement priority to foundation construction. So why we need to do the soil improvement? That because in the designing and financing of the foundation of superstructure, the enhancement of soft ground conditions can often limit the need for a deep foundation. Facility contractors routinely improve the performance of the ground in situ by compacting, reinforcing, or fixing soil masses and particles. Soil improvement for foundation is to improve engineering performance of soil such as strength, reduce compressibility, reduce permeability, or improve groundwater condition. Okay, so for the first one, vibro-compression. Vibro-compression is a technique that compacts granular soil and rearrange the soil particles into a denser state. This process involves the use of a downhole vibrator that is lowered into the ground to compact soil at depth. The method is used to increase bearing capacity and reduce foundation settlement and is more effectively in free draining granular soils below the groundwater table. And the vibrant flow consists of cylindrical steel shell with an interior electric or hydraulic motor that spins an eccentric wheel. So this is the figure of how the vibro-compression process. So for the next one is stone column. In this method of reinforcement, columns of compacted gravel-sized stone particles are constructed vertically in the ground. The column improves the performance of soft or loose soils, where densification of surrounding granular soil and reinforce of the soil with a stiffer, higher steel strength column. The stone is commonly compacted with a vibro float. This method is often used to increase bearing capacity up to 10 ksf and pre-collapse sinkholes priority to construction in karst region. Okay, so for the next one, the jet grouting. This technique serves as an alternative to conventional grouting, chemical grouting, slurry trenching, underpinning, or the use of compressed air or freezing internally. Jet grouting is commonly used to provide excavation support of an existing structure before an adjacent site is excavated to make way for a new, deeper structure. Jet grouting is effective across a range of soils and represents a bottom-up process. A drill flushes the monitor to the bottom of the treatment zone. The erosion and ground jets are then initiated as the monitor is rotated and extracted, which form a soil-free column. Rotating the monitor through a portion of a circle will create only a portion of a column. Extracting the monitor without rotating will create a panel. And this is the figure shows how the process of jet grouting. Okay, so for the conclusion, in this project, it was found that deep foundation is more suitable than shallow foundation on the type of soil profile in our project. This is because very soft clay is considered weak soil layer as they exhibit pore strength and compressibility. One of the conditions that required the use of pile foundation was compressible and weak upper soil layer. Hence, the very soft soil on top layer should be used pile foundation to distribute the column load to a stronger soil layer. Next, the justification of the decision to apply deep foundation is the presence of horizontal forces. Last but not least, the concern for presence of expansive soil. Hence, it can be concluded that deep foundation was the best foundation that can be applied on the soil profile that we have investigated on foundation of FEE building in UTSF. That's all for me. Thank you.